Okay, this video still goes with section 6.1, and 6.1 introduces what we call slope fields. And a slope field, all that it is it's a geometric representation of a differential equation, or it's a way to visualize a derivative, okay? Um, so slope fields are drawn on the lattice points of a Cartesian plane. So I'm talking about the actual at the point, let's say 1, 1. When I draw my slope field, I will draw it on that point. Okay, and I'll show you an example. So let's just look at the first problem on your worksheet. Okay, I'm supposed to draw the slope field of this differential equation, dy dx equals x plus 1. So let's talk about what this is. dy dx, we know that's the derivative of y. So we're looking at the rate of change. So they already found the derivative for us. So here's how we find the slope field. I'm going to make a basically kind of a t-chart. I'm going to choose values of x. I'm going to go ahead and write in my slope that they gave me. And then I'm going to have a column for my y value. Um, well, actually, I could put that y value over here, but that's okay. And we're going to draw a slope field for each point on this coordinate plane. Okay, so let's just plug in the point 0. So 0, 0. So if my x and y point right here at the point 0, 0, I'm going to plug these values into the equation. So in this case, I only have an x, so I don't even really need this y column. So when I plug um, the point 0, 0 in for my slope, and I'm going to go ahead and put my slope, I'm going to use that for slope, I get 1. So when I, at the point 0, 0, I need to draw a short little line segment with a slope of 1, positive 1. So it's going to look something like, and you just kind of have to estimate, something like that. Okay? So let's do our next point. Let's do the point 1, 0. So x is 1, 1 plus 1. So my slope is 2 at that point. Okay, so if this is the slope of 1, I need to make this line segment to where I can tell that it's actually a little steeper. Okay, a slope of 2. All right, so let's do the point 2, 0. So when I plug 2 in, I get a slope of 3. So at this point, and do you see that as I go, I'm going to get just a little steeper and steeper. So this would be 3 plus 1. My slope is 4. Okay. So let's go this way. Let's plug in negative 1. So when I plug in negative 1 into this equation, or into this slope, I'm going to get negative 1 plus 1. I have a slope of 0. Okay, and I'm just going to get rid of this y column right here just because we don't really need it. So how do I draw a line segment with a slope of 0? Well, a slope of 0 is just this horizontal line through that point. So now let's plug in negative 2. So when x is negative 2 plus 1, my slope is negative 1. So this time I need to draw a slope of negative 1. Now let's plug in negative 3 plus 1, that gives me negative 2. So slope of negative 2. So now let's do this point right here. Let's do the point 0, 1. Okay, my x value is 0. So do you see that right here, the point 0, 1, since my x value is 0, I have a slope of 1, which is the same as this. So I need to try to draw these to where they look the same. And do you see that this is the point 0, 2? So when I plug 0 in, I'm still going to get the slope of 1. So all of these should look the same because they all have a slope of 1. Okay, what about this one? This is the point 1, 1. Okay, well when I plug 1 in, do you see I'm going to get the same as this slope, which is 2? So all of these, I need to try to make them look the same, and it's kind of hard on mine. So all of these should look the same. And do you see that this point, which is, what is that, 2, 1, I get a slope of 3, so all of these should look like they have the same slope. Same thing here. Okay, and then if this is the point negative 1, 1, do you see that all of these vertically will have a slope of 0? These will all have a slope of negative 1. So again, I'm just trying to make these look the same. And these would all have a slope of negative 2. So this is the slope field for this differential equation. Now, somewhere on your sheet you need to write this. If you noticed, when I am in terms of x only, so whenever I have x is my only variable in my slope equation, that all of my slopes vertically will be the same. That's supposed to say vertically. Good grief. Okay, so I'm in terms of x only. So you can write this down, x only. My vertical strips will be the same. Or parallel, however you want to write that. So sometimes that's very helpful to know because if I just have an equation and I have to match up the graph of the slope field, sometimes I know that if I'm in terms of x only, I know to look for my vertical strips to all be the same. Okay, now let's look at another one. Oh, here's an example of sometimes they're going to have you, this would, okay, sometimes they're going to give you a slope field, and then they're going to want you to draw a particular curve through a given point. So here's the slope field that they've drawn for this differential equation, x squared minus 1. And if you'll notice, I'm in terms of x only, so that's why my vertical strips all match up. But then they want me to draw the slope field through the point negative 1, 3. So they've plotted the point negative 1, 3. They've already done their slope field, and then they just kind of sketched this curve following their slope field through that particular point. Okay, so let's do another problem off of your worksheet. dy dx equals 2y, so they've already found the derivative. Okay, I'm going to draw my little t-chart. In this case, I don't even need an x column, right? Because I don't need to plug in x here. So I have my y column. Oops. So my y column, 2y, and then I'm going to write down what my slope actually is. So at the point 0, 0, so when my y is 0, my slope is 0. So let's do the point 0, 1. So when y is 1, 2 times 1, my slope is 2. So I need to draw a line segment so showing a line with a slope of 2. Okay, let's do the point 0, 2. So when my y is 2, my slope is 4. So I need to draw a line segment through that point that shows that it's steeper than this. What about when y is negative 1? 2 times negative 1, my slope is negative 2. Okay, so it's going to go the opposite direction with a slope of negative 2. And I plug negative 2 in, 2 times negative 2, that's going to give me negative 4. So a slope of negative 4. let's see. So that's slope of -2. So 1, 2 that way. I'm trying to think here just a second. Okay, so a slope of -4, something like, oh, that's not very pretty, but let me fix that. Okay, so just a little bit steeper than this one. All right, so let's choose this point. This is the point 1, 0. So my y value is 0 again. So it's going to be a horizontal line. And you see that this time, all of these will be the same going this way. This way, all of those should look the same. Mine may not look exactly the same. Okay, and then this way should look the same. And if you're not for sure, um, you know, a slope of 2 or a slope of 4, as long as it looks steeper than the original one or the one before that, if it's supposed to be a steeper slope. So in this case, since I'm in terms of y only, so when you have y only, instead of vertically the strips being the same, your strips horizontal will be the same. Horizontal strips will be the same or will be parallel. Will be same. Okay? And then when you have one like number 6, okay, this is when you're going to have your x and your y values in there. So this is negative y over x, and then your actual slope. So when I have the point, let's do the point 1, 1. So my point 1, 1, that's negative 1 over 1. I have a slope of negative 1. Okay, so at the point 1, 1, I have a slope of negative 1. Okay, let's do the point 1, 0. So I have the point 1, 0. So I have 0 over 1, negative 0 over 1. So that's 0. So at the point 1, 0, I have a slope of 0. Okay. What about the point 0, 1? So I have negative 1 over 0. That's undefined. Okay. So what kind of line has an undefined slope? Okay, what kind of line has an undefined slope? Well, wouldn't that be a vertical line? And I want to look at something really quick. Oops. So when I have the point 0, 1, I have an undefined slope, and undefined slopes have, or lines that have undefined slope are vertical. So I have a vertical line at the point 0, 1. At the point 0, 0, I have negative 0 over 0. Again, that would be undefined. So that's where I was checking. We're going to put a vertical line here. Okay, at the point 0, negative 1, do you see I have negative 1 over 0? So all of the lines right here, those will all be vertical lines because my slope is undefined. But after that, let's do this point. This is the point negative 1, 0. So I have 0 over negative 1, that's 0. So at the point negative 1, 0. Okay, and do you see that all of these will be 0? Okay, like the point 2, 0, since I have 0 over that. Okay, but when I get here, like to the point 2, 2, the point 2, 2, that's negative 2 over 2. That's negative 1. So I have a slope of negative 1. A slope of negative 1. So this was the point 1, 1. Oh, so the point 2, 2. I have a slope of negative 1. Okay, so I got you started. I need you to go ahead and finish. But when you finish, you should have a picture that looks something like this. Okay, I haven't done all of them. But when you have x's and y's in your original problem, um, you're not going to have horizontal or vertical strips that all match up. Okay, so your job is to finish problems 1 through 6, and then on the back of that page, your job is to match up the differential equation with its slope field. So for right now, you're only doing problems 1 through 14 on your worksheet. So 1 through 14 on your worksheet.